This is a quick video on the base station, or what I've been referring to as the base station that goes along with the turntable controller. I am not going to be providing wiring diagrams, schematics, or anything like that for this portion of the build. This is very dependent on the stepper motor you use, the auto reverser you use, and really how you want your system to run. So I'm going to leave this out. Now, a high level overview of how mine works. So I've got 12 volt DC coming in, and then that 12 volt DC goes to my relays because that's the power that the relays need to actuate. And that 12 volt also comes to the stepper motor controller here. It then goes to a buck converter, which kicks that 12 volts down to 5 volts DC. And that 5 volts DC goes to the Ethernet breakout board. And this is, for you all to realize, this is what the turntable controller plugs into with the Ethernet port. Also, this Ethernet port provides signal from the turntable controller to the stepper motor. Important to know that this stepper motor controller that I made, it only works with 4-wire stepper motors. So if you have a 5-wire system, you got to figure something else out. Your motor controller needs to be able to take 4 wires only. Also, 5 volt DC signal comes from the controller to these relays, which will activate these, in my case, these relays to do my auto reverser. If you're using a different auto reverser, you get a 5 volt signal out from the Arduino Mega to control the auto reverser. This breakout board also sends power in my design to the turntable controller through this Ethernet port. You need to verify that your buck converter, your power supply, all of that does not overload your Ethernet cable ampacity. I'll leave that up to you guys. I haven't had any issues, but I'm not going to take responsibility for that. One thing I did with my controller is that my breakout board has a shield connection, SH. I use the shield connection as the ground for this system. I find that it helps alleviate a whole bunch of noise created from, for example, the stepper motor controller, the relays pulsing, and since this is close to the turntable itself, it helps negate any like actual DC motors in the trains causing any issues. In addition to that, you can see here, I actually thought this was pretty clever. These are just audio cable plugs. So I don't know if you remember back in the day when you had audio systems and you had the speaker wire and you had to just put the speaker wire in there and it pulls. I bought 2 of these and I use these to connect the wires from the layout here. So like your input power for the trains and your output power to the from this base station to the tracks on the turntable. It goes here. Again, I'm not going to tell you how I have all this wired, but I thought that was pretty slick. I was editing the base station overview tutorial and I realized that I left out 2 really important things. First is, like I said before, you've got your stepper motor driver up here, right? And it gets signals from the turntable controller through this Ethernet port to the Ethernet breakout board. Now don't quote me on this, please look at the table 1 that I provide with this whole project, but I believe pins 10, 11, 12, and 13 of the controller terminate on pins 1, 2, 3, and 4 of the Ethernet breakout board, which then are basically the same pins 1, 2, 3, and 4 of the Ethernet breakout board in the base station. One would assume that you take pins 1 from here, go to pin 1 to here, 2 from the Ethernet breakout board to 2 on the driver board of the stepper motor, and so on and so forth. Unfortunately, that's not the way it works, and I don't know why. So if you're having issues where your stepper motor's acting erratically or making some really terrible noises, you might have these wires in the wrong location. So for example, right now, my Ethernet breakout board, pin 1 from the Ethernet breakout board goes to N2 on the stepper motor driver. Wire 2 on the Ethernet breakout board wraps around and goes to N4 on the stepper motor driver. Out 3 on the Ethernet breakout board flips around, and I should have probably prepped this beforehand. That goes to N3 on the stepper motor driver, and last but not least, but pin 4 on the Ethernet breakout board goes to in 1 on the stepper motor driver board. So please note that at least for this driver, the pins are a little bit different than what you think, and you might have to play around with it a bit to get it to work. If you're using the same driver that I am, that comes standard with the 28 BY, whatever it is, the stepper motor that I call out on the manual, this is what comes with it. And it's actually kind of nice because it has these lights that light up when each stepper signal gets a signal. And you should be able to easily tell if you've got everything wired properly. 1, because the motor will be acting properly, but 2, because these lights will actually go smoothly up or down. So right now I'm pressing clockwise in step mode on the controller. You see how the lights easily go up? And if you go counterclockwise, the lights go down smoothly. Now if I had any of these wires in the improper place, it would look like sporadic lights, or the lights would be out of order. Something wouldn't be right. You'd be able to tell really quickly that that's the issue. The other thing I failed to mention is the Hall effect sensor. So I call out what Hall effect sensor I use in the manual that I put out, but this is another view of it. It's got a Hall effect sensor with a built-in breakout board. Now, how this controller works, or the base station works, I've actually built a plug into the side of mine, and then I created a wire that comes out here and then attaches to my Hall effect sensor underneath my turntable. So that's what this port is. Whenever you buy these, be careful because the wiring of them, it's not like, I think it's actually, it goes, and don't quote me on this, I think it goes negative, positive signal or something like that. It's not quite the same as a few other things. So whenever you buy a Hall effect sensor, make sure you look at the documentation that comes with it and wire it up properly. And what this does, again, is whenever it detects the magnet, it sends a signal to the stepper motor controller through the Ethernet breakout board, and that goes into pin 5. So I wanted to make sure I threw that in there so you all kind of knew an issue you might run into is that these inputs from the stepper motor controller might be wrong, and also where the Hall effect sensor, at least in my base station, hooks up at. So that's a quick overview of the base station. Again, you need to figure this out on your own, but I want to give you a high-level overview of what I did.